Hello. Can AI be conscious? Can it reach superintelligence? We're gonna tackle some big questions today. As an engineer, I try to stay away from philosophical and metaphysical aspects of this question and keep it very simple. I have one specific tenet which I always keep in mind, which is that I see no reason why machines made of meat, that is us, should be superior to machines made of transistors, which means intelligent or superintelligent or conscious AI has no roadblocks in my view. And you can delve into philosophy and metaphysics all you want. If you're not breaking this tenet, I'm fine. I don't have a problem with that. Well, until the recent developments have shaken it up a bit for the first time in 10 years. Just a tiny bit, but as I did more research into this, the things got pretty weird. One note, I'm not interested of how or why machines and humans can become conscious. So we will leave the hard problem of consciousness, the mystery of subjective experience, integrated information theory, and so on aside. We're not going to talk about that. We know for a fact that we are conscious, and this is all what matters. For my central tenet, I'll remind you, meat machines should be no better than transistor machines. Actually, meat machines should be worse since they do not scale very well. Engineer here. So in order to explain what happened, we will have to start with Gödel's incompleteness theorem. We won't go very deep into it, but basically the main thing you need to know about it, that in any formal system of rules like math, Gödel showed that there will always be some true things which are unprovable using all of these rules. So no matter how smart the system is, it will never be able to explain all the things about itself. It's a fascinating process of how Gödel did this, by posing a paradox, really, like this statement cannot be proven, and then he would express it numerically, and thus having a mathematical statement which refers to itself. Again, no need to get into this too deep. Just remember this, no formal system can be complete. That is, explain everything about itself. There will always be some truths which cannot be proven within the system. Now, some years ago, a famous physicist, Roger Penrose, used Gödel's incompleteness theorem to come up with an idea which is very much opposite to my central tenet. He argued that since AI, at least in its current form, is based on formal rules, mostly it's just pure math, some matrix multiplications and a bit more math, that's it. So this system will contain true but unprovable statements. He also had this idea that human reasoning can somehow access the truths that no formal system can fully capture. That is, it could work outside the Gödel's incompleteness theorem. But why? Well, I don't really see the reason why our brains, which are, remember, meat machines, why we could not be formalized. Well, and this is a big reveal, unless the meat is quantum. Oh my, why am I doing this? You see, we have a big problem here. Attempts to connect quantum effects to human body, if we have long been the hallmark of the most despicable pseudoscience. This was peddled by various New Age gurus like Deepak Chopra, Amit Goswami, and the whole quantum mysticism movement. But this is Sir Roger Penrose. He won a Nobel Prize for his research on black holes, and for a very good reason. He's a genius. He is no Deepak Chopra. What's happening here? Well, if we read on, Penrose seems to argue that the wave function collapse is a basis for non-computability. Just because the wave function collapse is a random process, essentially, it doesn't mean it's not actually computable within a formal system. You can have probability functions in a formal system. Randomness alone will not get you there. But Penrose, he goes a step further in here. He seems to use randomness as a starting spot, and then sort of involves quantum gravity in this. That's a bit too deep for me, I have to agree. This is obviously speculative, but let's give Penrose, benefit of a doubt and assume that quantum effects on their own are enough to break Gödel's theorem. But still, can we even have quantum effects in our brains? Well, for starters, Penrose did not really provide any framework of, how could that happen? And it shouldn't. It really makes no sense. Brains are warm, and, quantum computers, for example, operate in near zero Kelvin temperatures. Brain is also big and slow, and quantum effects, they usually dissipate in nanoseconds, and brains are much too slow for that. And we did not even get to the fact that there's no proof whatsoever that any quantum effects would affect consciousness, right? Well, this story evolves a bit. So there's another, also very smart guy, Stuart Hameroff. He got a candidate of where these quantum effects could be happening in our body, microtubules. Since he was an anesthesiologist, he noticed that microtubules play a key role in our brains producing consciousness. And that's it, really. He didn't need to talk about anything quantum, but if quantum effects would happen somewhere in our body, microtubules seemed like a good candidate. They are present pretty much everywhere in our bodies, and also neurons. And, well, I don't think it's debatable that neurons certainly cause consciousness. So together, Penrose and Hameroff, they came up with this theory, orchestrated objective reduction. Highly controversial, yeah, right, in which they postulate that consciousness originates inside the neurons at a quantum level. You need not guess that this theory was heavily criticized by other scientists, and it was deemed extremely speculative. It took its place as maybe not totally pseudoscientific, but definitely extremely fringe idea. And for a good reason, since there's no direct evidence whatsoever to connect the microtubules and quantum effects to consciousness. Not at all. I think there's also a question about the motivation. Why are we even doing this? It seems to me like Penrose and Hameroff were looking for a knowledge gap to fill. People have been doing this for ages. A few thousand years ago, you would see a lightning appear, and instead of saying, oh, I have no idea what it is, you go on and explain that actually, oh, there's a man in the sky on the cloud, he's throwing lightning bolts at us. We would get more knowledge as time goes on, and science would fill some of the gaps, but people wouldn't stop. They would find the next gap and put all the supernatural stuff, in that next gap. And it feels to me like this is just one of the attempts, really. So this all started in the 90s and was happening for a while, until 2024. And out of the blue, this paper comes out. Superradiance observed in microtubules. What? What's superradiance, by the way? I'm gonna go a bit deeper into physics and chemistry of all of this. Not really the subject, I feel super comfortable in, so I will try to keep things simple. So let's first chat about the terms which we will encounter in this paper. The most important thing is fluorescence. So, of course, we have fluorescent lamps, paints, materials. In a very simplified manner, it's when you provide some energy to an atom or a molecule, and it excites it, puts some of the electrons into the higher energy level, just for a few nanoseconds mostly, and then the atom or molecule goes back to its default energy state, also emitting a photon. It's a well-established phenomenon. In case that molecule was excited by light, usually UV, it will also have this property called quantum yield, which is pretty much the efficiency of a material in this regard, a rate of emitted photons to the absorbed photons. And quantum yield will come up shortly. Another thing which we need to know is tryptophan. Tryptophan is amino acid and is present in common foods. It's an important component in a protein called tubulin, which in turn is a building block for microtubules. That's the same thing which Stuart Hameroff proposed to be responsible for consciousness. We also know that tryptophan forms these large networks within the microtubules. So fluorescence, quantum yield, tryptophan, they're all connected since tryptophan is fluorescent. It can absorb UV light and then release it back. So it also has this quantum yield. Look here, this part is a climax. So when forming biological architectures, these networks, tryptophan molecules exhibit superradiance. What does it mean? Well, the light emission was different in networks when compared to single molecules. It was both stronger and faster, meaning the quantum yield, it depends on whether the tryptophan is alone compared to whether it's in the network. And this is huge. They did not observe any ions, floating between molecules, no chemical reactions, nothing. And yet these molecules still knew about each other. In a classical model, you would expect each molecule to emit light individually and independently, and they do it alone. But when tryptophan forms these biological networks, quantum yield changes. We then observe them emitting light in a coordinated manner. We're in the quantum world now, and that's how this effect is called, quantum superradiance. It means that different tryptophan molecules have some quantum coherence. Their wave functions basically align when within these networks. How? Well, that's beyond my paycheck, but yeah, it does seem like it does happen. And even though they did this in the lab, not in the actual brain, these tryptophan networks are very much present inside our neurons. The meat is indeed quantum. Okay, I have to be honest. Even though this seems huge, all of this is still an extremely long shot. Superradiance was observed in a lab, not in an actual brain, right? We still need to show this happens in the brain. Even though we show it, whatever was observed here, this is confined within a single microtubule, and there's many of them within a single neuron. We have no evidence that the quantum coherence is happening between the different microtubules. Even though, if we do find quantum effects between the different microtubules, we would then be confined within a single neuron. We have no evidence of quantum effects between different neurons. Our neurons do synchronize, by the way, but we do it electrochemically. Even then, I'm not entirely convinced that introducing quantum effects makes Gödel's incompletence theorem not apply. I think we would still be able to formalize the brain even with quantum effects. Even if we do formalize, there's still no obvious link from any of this to actual consciousness. Even then, I'm not even convinced you need consciousness for actual intelligence and thus superintelligence. So why am I even fussing about all of this? Well, because Penrose is a genius. Or maybe he's a time traveler, I don't know. He just knows it to be true but cannot properly explain it. This is pretty infuriating, actually. I had this strong tenet of meat machines not being better than transistor machines for all these 10 years, and now I don't know what to think. And also there's this freaking elephant in the room, which I cannot even tell you about. Damn.